Subscribe to AmpCode and ring the notification bell to get the latest content.
So in the previous lecture, we have seen all about the different libraries that Spark provides to work with the relational data, unstructured data, as well as the real-time data. So we have seen how we can utilize the Spark MLlib library to utilize it and how we can run different machine learning algorithms on top of our data frame. So here we are going to see all about the new capability of Apache Spark, which is GraphX. So GraphX is nothing but a top level API on top of the Spark core, which is nothing but RDD, to able to work with the graphs, which is nothing but consist of nodes and relationships. So many of you might not be aware of what is a graph database and how it works under the hood. So we are going to discuss it, and also we will see a simple example of how you can create a RDD on top of some data as well as convert it into a graph, and also try to extract some meaning out of it. And also at last, let's also cover some of the basic concept of data warehousing and the lake houses, and we will also compare them and decide which one will be more suitable for your use case. So this is going to be very fun. So without further any ado, let's get into it. So first thing first, let's talk about some of the basic introductory part of Apache Spark GraphX library. So basically GraphX is a pretty new component and many of you haven't maybe heard of it. Everyone knows about the MLlib library, the Spark streaming, but many of us don't know about the GraphX library. So it is nothing but a new component of Spark for graphs as well as the graph parallel computation. So it takes the advantages of parallel computation to get the hidden meaning out of your data, and this data is not structured. Graph means the data is stored in NoSQL format, which is the graph database format, which is nothing but consists of nodes as well as the relationships. So basically at a high level, it is nothing but it extends the Spark RTD by introducing a new graph abstraction. So it's a totally different abstraction. So we have seen all about the RDD, which is nothing but a primary abstraction, and also we have seen about the data frames, but graph is a completely different approach. So let's talk about the property graph and the examples of property graph to get you better understanding of what is graph really and how it compares to the traditional approaches like data frame, RDD, or even the RDBMS databases. So the property graph is nothing but consists of the vertices and the edges, which is also represented as the nodes and the relationships. So basically it is a directed multi-graph which consists of these nodes and relationships. So as you can see in this figure, we have the vertex table which consists the data of all the vertices, as well as we have the edges which has all the data of the edges. And as you can see, we got a property graph which consists of this data. So the right hand data is consist of pretty structured format. We have a different table of vertex and different table of edges, but combining those will convert it into the graph. So as you can see, this graph has all the data like the properties. So every node and the relationship can have a property assigned to it, which nothing but contains the actual data. So we can compare it to the RDBMS. So basically in RDBMS we have a table. So we can have, like for an employee database, we can have employee table, salary table, department table, and so on. So similarly we can have a label in the graph database. So basically label will represent and groups the data together or nodes together. So we can have like a different label for employee. So basically employee will be a record and the label assigned to it will be employee. And also we can have a different label like the department, the salary, and so on. And also all the properties means the values that are present in each rows in RDBMS. So all the data present in the RDBMS, you can say it as a property in the graph database. And also the relationships is nothing but the foreign keys, primary keys present in your RDBMS. So basically your employee table and salary table will have some key which is nothing but the employee ID. So this is just an example. Your key would be anything you want to keep. So for example, we have an employee ID between the employee table and the salary table. Similarly, we can have a relationship between all the records. It is not like it is table to table relationship. In graph databases, we have relationship between all the nodes that are there in the graph. So it takes the advantage of the relationships to get you the hidden patterns in your data very efficiently. So that's why these graph databases are pretty popular nowadays and used for active fraud monitoring as well as the recommendation system. So if you know about Google, the suggestion pages, those cards are nothing but backed by the knowledge graph, or we can say the graph database, which give you the recommendation of your search result. So also LinkedIn uses their own graph database which is native to them to get you like the first level connection, the second degree and the third degree connection very efficiently. Because if it is backed by the relational databases, the query will suffer and you will not get the data to third degree connection. So if you go ahead on the LinkedIn and search for any person and you are filtering based on the third degree connection, then that query might be impossible to process on the billions of records. So that's why many of the popular platforms are already using graph databases to leverage the recommendation system as well as the fraud monitoring and as well as in healthcare department to detect any vulnerability.
So that's it for today. I'll see you in the next lecture.